welcome back to my channel. Don't forget to like, subscribe and share. So today we're still talking about the exposure of artificial intelligence to the community. My name is Boa Haula. So this time around we are going to deal with the topic of recommending a customer to purchase the best used car. So as we all know, the importance of having a used car, as you're yet to see. And so first of all, these are the contents to the presentation. You're going to have the following to talk about. You're going to talk about a lot of different things. So let's start with the introduction. As I've told you, the importance of buying a used car. So we have many advantages. So the many advantages of buying a used car. First of all, when you buy a used car, you're able to know because you're going to get a car that suits your financial capabilities. Even though you have, because you may want a car, but you can't afford it when it's new. So it's easier to afford it when it's used. And so in order to get such a kind of a car, following things should be done. So for example, one can drive and test the car after checking the car inside and out. Because the driving experience before buying is one of the ways to check the engine, the condition of the car, so many things can be tested. And the other thing we're going to talk about, so it's our problem statement. So our problem statement is more of our title, as I've told you, to recommend the purchasing of the best used car that matches the customer's interests. So someone may come and afford with such and such and kind of a engine, with this fuel type, transmission type, anything, what your man know, so you can know like what you want. So, and what we should know, although the beautiful appearance may hide many internal defects, so in order to avoid fraud when buying a used car, it is necessary to test the used car before what? Before buying it. That's the major thing you should know, like you should always test it before buying that kind of a car. So we're going to explain how the data set will be used to address that problem. Since I selected my own data set, like the one I should use, and then so furthermore, like if anyone needs a data set, you can try this link here. Yeah, it has many data sets, so you can search the data set you want. So according to how I'm going to use the data set, since this dataset contains all the relevant information that is provided on car sales, including columns, so it has columns like price, condition, manufacturers, and many categories like fuel type. So this enables the customer to choose the vehicle that matches his interest. And the customer will be able to enter specifications he wants. And if they are matched with some certain cars in the data set, though there is going to be a list that is brought, so one will be able to choose the most efficient, like which matches the color, the everything that matches his interest. So this is the link, as I've already told you, and we have the factors that I considered when selecting the dataset for my project. So there is the size of the dataset, adaptability with the project, ease of use, execution speed, and the source of the dataset matters because you're not going to get datasets from anywhere. Some things are not trusted and you will not have the technical support you need in case of anything. And this dataset has data, like it doesn't have null data. That's why I chose it like. So then we have the important features of the dataset that the AI model will use to solve the problem. So we have the price, we have the road tax, we have the transmission, the mileage, we have the fuel type and the engine size. So as for the price, this enables the customer to know whether the car fits his financial status or not. And the road tax enables him to know whether he can pay the tax like on an annually basis, the fuel type to know whether it's diesel or petrol. And the other thing, we have the Bayesian theorem. So this refers to the mathematical formula for determining the conditional probability and implementing machine learning. So this theorem deals with belief and related evidence. So this is the formula, the general formula of the theorem, and we have the applications. We have drug testing, cancer testing, whereby we're going to replace A with cancer and B with the symptoms, whereby the A and the B you change to symptoms are cancer. That's how you're going to use it to calculate the cancer rate. We have the defective item rate, recreational math, and sensitivity or specificity. So we have our next part is the naive Bayes, and this is a machine learning algorithm we use to solve problems. So it is based on the Bayes theorem. That's why they have almost similar methods, and it's one of the simplest machine learning algorithm in use. So it's used on numerous data points, and one has many variables to train the data set. So in case you have many variables to train the data set, we can use it since it's faster and it can do a lot of things. And the advantages of the classifier. So this algorithm works quickly and saves a lot of time. As I've told you, it's faster and it's suitable for solving multi-class prediction problems since it first classifies them. And if the assumption of features holds true, it can perform better than any other model. So, and it needs less training data. Since it's a classifier, you're able to know this is this, this is this, and it is suitable. So it is more suitable for categorical input variables than numeric. So, and this is the easiest. So the application of the naive Bayes, we have the sentimental analysis to know whether it's a product or service. We have the text classification. This is used for solving multi-class problems. And we have recommender systems to know whether when I want this kind of information, I'm using Amazon or Netflix. So, and you're able to learn more machine learning algorithms with this. So, our next thing is Bayesian networks. So this is like a graphic model. It's a graphic model that presents a set of variables and their conditional dependencies via a directed graph. So you're able to know like when you're directed to a cyclic graph, you know, so since it's a graphic model, it represents variables and each variables has two values. It's either true or false. And it has, sorry, it's not either, it's both true and false. And for these Bayesian networks, it's easier for humans to understand. So it's human friendly and it could be used to represent the relationship between diseases and symptoms. And the other thing about these networks that enable sequences of variables. So they have types. We have the dynamic and we have the dynamic Bayesian networks and the influence diagrams. So these are used to solve decision problems and the uncertainty, the influence diagrams. And so we have the two main interfaces of the task. So these Bayesian networks can be used in inferring unobserved variables, parameter learning, and structure learning. I'll further explain this in my next video. So we also have the differences between the naive Bayes and the Bayesian theorem. So this, first of all, the naive Bayes assumes conditional independence, whereas the Bayesian theorem does not. And this is a classifier, the naive Bayes, while this one is a theorem. So a naive Bayes, it's a machine learning model, unlike the Bayesian model. So, and this is simpler and it's more quicker, as we've said. So we also have the differences between naive Bayes and Bayesian networks. So these are the differences. First of all, the Bayesian network deal with the Bayesian inference. So, and the naive Bayes deal with the Bayes theorem. So it is based on application of the Bayes theorem. That's why they almost have the same method of application. And we have many differences. We have these each nodes in Bayesian networks represent random variables, unlike the naive Bayes. And the one specific feature that does not affect the naive Bayes, unlike in Bayesian. So we shall not spend a lot of time there since they're well explained. And these were the most relevant references to my work. And in case of further reading, you can tap them and then know and further get more knowledge about them and acknowledgements. So I thank you very much for listening. Thanks for your time. I appreciate. Don't forget to like, subscribe, and share. Have a nice day.